Topic 9 talks about data analysis and statistics. Statistics is known as the study of the correlation, organization, analysis, interpretation, and presentation of data. It's also known as telling a story with data. The first statistical measurement is the mean, and this is defined with a bar over the x, and it is the sum. The e is equal to sum from I equals 1 all the way to n, and n is the number of elements in the array, or the amount of data. So x of I times 1 over n, so the sum of x of I times 1 over n, and its function name in MATLAB is mean parentheses x, and it measures the central tendency or the average. The next two are the median and the mode. So the median is the middle value of the array and the mode is the most frequent, and in MATLAB the function for median is the word median times x in parentheses, and mode is mode times x in parentheses. The next statistical measurement is standard deviation, which measures the variation from the mean or the spread of the data. The equation for standard deviation is 1 over n minus 1, so 1 over the element number n minus 1, all times the sum from I equals 1 to n of x of I minus the mean of x squared, and it's the square root of all of that. And the function in MATLAB is std of x. The next statistical measurement is variance, and it's the same equation as standard deviation, just without the square root. So it's the sum of x of I minus the mean of x squared all over n minus 1. And it measures how much variability is in the data, and in MATLAB the function is var in parentheses x. Next is the covariance, which is kind of like variance, but instead the equation is the sum of I equals 1 all the way to n times x of I minus the mean of x times the y sub I minus the mean of y all over n minus 1. And it's measuring the strength of correlation between two data sets, so you need an x and a y. So the function in MATLAB is COV in parentheses x comma y. The last statistical measurement that we're doing in this topic is correlational coefficient, which is basically the covariance all over the square root of the variance times the covariance, and the equation for this is the sum of x sub I minus the mean of x times the y sub I minus the mean of y all over the square root of the sum of x sub I minus the mean of x squared times the square root of the sum of y sub I minus the mean of y squared. And in MATLAB it's the core coefficient of x comma y, which the function would be CORRCOEF, core coef of x comma y, and it finds the correlation between data. This example shows good correlation versus bad correlation. So bad correlation is on the left, where it has no correlation at all. You can see it's 0.0 of monthly sales by traffic count, and on the right it's closer to 1, so it kind of has a really good correlation because the dots are more in a line, but on the left they're not in a line.